Still sipping, feeling better, still having some throat things going on here, so pardon me whilst I sip. Today, guys, here, 8th grade class, what we are going to do is we are going to pick up on the reading assignment that you had here with regard to Chapter 10, the section for weight and balance. Notice not just the crazy eye movement that I had there, but the fact that I separated the term weight from balance. The reason I do that, so many times in our lexicon of aviation, we refer to it as weight and balance. We just throw it all in there as one word, like it's just one thing. Well, make no mistake, it's two things. You have a weight that we're going to be working with regard to the weight of the aircraft when you get everything in it, not just the weight of the airplane, but the passengers, the bags, the fuel, the oil, all that stuff, so that you have a maximum ramp weight, perhaps, of this particular airplane. And we have that we look at not just the weight, but the balance part of it. Where is all this weight? Is the weight evenly distributed through the airplane and your center of gravity is within these prescribed limits that you have? Or are you out there in one of our Diamond DA-40s and has somebody put a grand piano in the back of it? Is that going to be okay? Well, we're going to find out if it's going to be okay, and if not, what to do about it, okay? So that's kind of what we have to do. We do weight and balance calculations before we fly, period. Every single time we fly, we do a weight and balance calculation. You have to. You have to know if the weight is within limits and is the balance within limits. And you'll find out that that scale can move based on the weight. So it's not always in one spot, and you have to find out. You have to know for each aircraft that you fly. Also, one of the things that the FAA does is they want to make sure that you're not taking off with an airplane that has a weight or balance issue. But they don't do a very good job of talking about what happens to the weight and the balance of this airplane in flight. Are you going to be able to land that airplane within limits? That's one thing they don't do a great job of talking to you about. I will, okay? So that's what this is for. This is going to be the intro piece for this. So I'm going to do some talking and some drawing and some other kind of, edubabble stuff here. And then you're going to do more reading. And then on Friday, we're going to do some of these calculations. Okay? So that's what we're going to do. So what I want to show you first here, again in Chapter 10, is we talk about this, and we talk about, first of all, kind of the weight of the airplane. We know that the weight of an airplane impacts a lot of different things with regards to how that airplane, or if that airplane, is gonna fly. So we have to talk about those things, and we have to know what it is. So I want you to know all of these bullet points. When it says the most important performance deficiencies of a loaded aircraft are, in other words, what that means is, what are some of the bad things that a heavy airplane can do? So with this, you've got a higher takeoff speed, longer takeoff run, reduced rate and angle of climb, lower max altitude, shorter range, reduced cruising speed, reduced maneuverability, higher stall speed, higher approach and landing speed, longer takeoff roll, excessive weight on the nose wheel and or tail. How many awesome things does weight add to the equation? Well, not many. Unless you're thinking about carrying that extra passenger. Oh, I get to carry an extra passenger. Okay, there we go. Yeah, you might be able to take more people and more bags. That's always a good thing, depending upon what your mission is. But you have to know that everything that goes into that airplane you have to account for from a weight and balance standpoint. So understand that just like high density altitudes can cause problems with the performance of an airplane, a heavy airplane also is not going to fly like a lighter airplane. You have to know that. So it comes at a cost. What is that cost? Greater fuel consumption, may not be able to land where I want to land, may have to find an airport that's got a longer runway, I may have to, you know, all these different things that you have to do, you have to kind of think about those things. But again, don't think of it in just the terms of getting off the ground. At some point, that airplane is going to be put back on the ground. It's going to be up to you as to how elegantly that happens. So you have to know what happens to the weight and the balance in this in flight. Okay? So, more on that later. So here we look at this. We look at the, the weight. How does weight change? Well, the one thing that happens when you're up there running that little spinny thingy at the front end of that airplane is you're burning fuel, right? So you are actually losing weight as you fly. Well, is that a good thing or is that a bad thing? Well, in the Diamond DA40, it's really not going to be a bad thing at all because it's going to make things a little easier for you when you land. But in the Stationair, that can be a little bit different. The reason being is because my airplane is a lot heavier in the nose. And if I'm flying that airplane with just me and no bags, if I go with full fuel, as that fuel burns, my CG moves forward and forward and forward. If I'm not very careful, when I land that airplane, as I have used most of the fuel, I may not be able to bring the nose up sufficiently enough to land that airplane without damage. And you're thinking, well, why would they make an airplane like that? Well, they make the airplanes like that to haul a bunch of stuff. And it flies better and it's happier when it's got a bunch of stuff in there. But again, I don't always have to carry a bunch of stuff in there when I fly. So when I do, I need to account for that fuel burn and that reduction of weight in flight and have some form of ballast or weight that I have in the tail to make sure that when I land that airplane, that in that CG, that loading envelope that I have, that I'm still within that envelope, so I know that I can count on good elevator performance at low air speeds, because that's what's going to be able to raise my nose, is that if I can lower the tail, right? So that's what I'm counting on. But if I just did it without anything else in the airplane, I could have a problem when I try to land the airplane. That airplane it kind of has an accident history that is caused by PIO, pilot-induced oscillation. And what happens is that pilots will come in with a light airplane, that nose is going to be heavy, they don't have the elevator control that they thought that they were going to have, they try to flare that airplane, and she don't want to flare. That nose wheel just wants to hit the ground, and when it hits the ground, it can bounce. And when it bounces, if you don't correct for it immediately, that nose is going to fall back in, you're going to have a prop strike, and it's going to be an expensive day. So that's kind of one of the things that I know going in that I constantly have to be aware of when I land the airplane. So that's one idea. Another thing has to do with this. With some aircraft, you'll have like a maximum takeoff weight. Let's say that it's 3,817 pounds. Where do I get that number? Well, that's the max takeoff weight of the Stationair, 3,817 pounds. But it has a max landing weight of 3,600 pounds. 3,600 pounds, that's the max landing weight for that airplane. That's just over 200 pounds. What the heck? What do I do if I take off max weight and then I need to land that airplane immediately? I've got to think about that before I go. And I have to know, here I am at max takeoff weight. I've got 200 pounds that I've got to shed somehow before I can put this airplane on the ground. So in a lot of cases, it has to do with burning fuel. Unless I just want to throw a passenger overboard. Yeah, probably not. Okay, those are some of the considerations. The fuel, where does the fuel go? The bags, where do the bags go? I'm showing you this picture again. What about if the bags move? In this particular case, there's not a lot of place for those things to go. But what happens if that cargo moves? There is a horrific video of a 747 cargo jet taking off somewhere in the Middle East. And it takes off, and in the video that was actually taken by a dash cam of some driver in a truck driving by the airport, you see this 747 take off, and it just keeps rotating, 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 and it tries to go up, lowers a wing, comes back down, crashes, and explodes. This aircraft was carrying a tank. And what they think happened is that on takeoff, when the airplane rotated, something happened with the chains snapped, the tank moved further aft in the aircraft, and you couldn't control the airplane. Is number one, going to be less stable to begin with, but two, you may not be able to recover from a stall should one occur, because all of that weight's there. To recover from a stall, you got to get that nose down. Well, if you've got a 55-ton Abrams tank that has just slid to the back of your airplane, you may not be able to get that nose down. I'm speculating on that because I haven't seen the actual finished version of what happened to that airplane. You know, you can Google it, I guess, if you want. But that's just one of the more dramatic episodes that I've seen of an airplane that had a cargo shift that caused a horrible accident. So those are some of the things on the weight changes. You think about changing weight, but a lot of times you don't think about changing its position, but in some cases that can happen. So the effects of adverse balance, you guys can look at this. Do you think it'll affect stability? Yep. And again, just as we talked about here with stability and the center of gravity, that's a big thing. Do you think it affects control? Yep. Just for the reasons that I just talked about the effects of control. So it comes down to the management of the weight and balance. That's what we have to look at. It says right here that while there are no specified requirements for a pilot operating under 14 CFR Part 91, which is what we do, to conduct weight and balance calculations before each flight, 14 CFR Part 61 Section 91.9 requires the pilot in command to comply with the operating limits in the approved AFM. Those limits include the weight and balance of the aircraft. And so with that, the AFMs, or the POHs, and we all know what those are now, will have a graph in there for your particular aircraft type. However, the actual weight and balance numbers themselves will be on a separate sheet of paper, one of the 4 documents that you have to have on board the airplane each and every time you fly. One is the airworthiness certificate. Second one is the registration. The next one is the pilot's operating handbook, or the AFM. And then the fourth one is the weight and balance sheet. AROW, A-R-O-W. The airworthiness certificate, the registration, operating handbook, and the weight and balance sheet for that particular airplane. That has to be on board the airplane anytime that you fly it, for you to fly that aircraft legally, okay? And the reason it's so important is because of the reasons that they just said here, is because if you don't have the airplane loaded within limits, you may not be able to fly it. And if you can fly it, you may not be able to recover it if something happens. That's why we do it. Each aircraft is, when it's inspected, anytime equipment is either added or taken away from it, a new weight and balance sheet has to be prepared by an authorized mechanic or service person to be able to do this. Because the weight and balance is so important, each particular aircraft has its own. It's not like a Diamond DA-40. Here is the basic empty weight of a Diamond DA-40. Each one is different. Each one has different equipment in it. Each one has different manufacturing things, and it may be a couple of pounds difference between one and another. Well, you need to know what that is, because you're going to have a max limit, and you need to know, here's the base, here's what it is, let's call it 1,800 pounds, and I know that my max takeoff weight is 2,646 pounds, so here I go, 1,800 this, I have basically 846 pounds that I have to play with here. I've got to factor in my fuel, have to factor in my oil, and then that's going to tell me how many passengers and bags I can put in it. So that's kind of what we have to do when we look at these weight and balance calculations. So we look at the terms and definitions. Now, under the terms and definitions, you have the arm. This is what we refer to as a moment arm. Now, moment, a lot of us think in terms of time. When we talk about this with regards to mathematics and physics, moment is going to be the effect of something. So we'll talk about that here in just a second. So if we look here, the moment arm, it has to do with a particular distance. And so if we look at a distance from a particular thing, this is where we determine what the length of that arm happens to be. Basic empty weight, we just kind of talked about that. Center of gravity, we sort of talked about that. CG limits, CG range, datum. Where do we begin measuring that arm? We begin measuring that arm at a particular datum or datum plane, a certain place that we begin. For the Diamond DA-40, that certain place begins at the spinner. For my aircraft, it begins at the lower firewall, which is going to be that point behind the engine and right there at the front of the firewall of my airplane. So it varies. Cirrus, they've got this point out in space, out somewhere out in front of the airplane that you begin measurements, and I've never really understood that. But that's where you start. And that's kind of where it is. It has to do with that reference point of where you begin the measurements for the arm. Delta, this is a change. Anytime that there's a change of value, we talk about that as being a delta. Fuel load, you guys can read all of these, and I know that you already have, because I know that you all did the reading, and I know that you know just how important anything that is a bullet point is. So understanding what these terms and definitions are is extremely important, so that you know what it is in the world that we're actually talking about. So that when I talk about something like mean aerodynamic chord, you know what that is, right? So, moment, the product of the weight of an item multiplied by its arm. Moments are expressed in pound inches, at least that's the way that we do it. And the total moment is the weight of the airplane multiplied by the distance between the datum and the CG. We'll talk about what that looks like there. But I want you to think of moment as like an effect of something. So for instance, we'll do a demonstration in the classroom on Friday. But there will be a demonstration that we'll do where we'll take a weight, and that weight is going to feel differently based on where I put it. Okay, so we'll talk about that in class on Friday. We look at this, the moment index, payload, standard empty weight, standard weights. These are things that you have to know. And when I say that you have to know them, I want you to be prepared to know these things by Friday. How much does a gallon of aviation gasoline weigh? What does Jet A weigh? How much does oil weigh? How many quarts in a gallon? How much does water weigh? Know that by Friday. Station. What is a station? Remember, we begin measuring the arm at the datum plane, or that datum point. That is the reference point where we begin the measurement. We end the measurement at a particular station somewhere along the way. And when we do this kind of down sort of from the spinner down the longitudinal axis of the aircraft to particular points, okay? And useful load. So remember, we have payload up there, and then we have useful load, okay? So, understanding that. Principles of weight and balance computations. Well, when you look at this, and you look at the example that they have here at the top, here at 10-3, this is a thing where you have at a fulcrum point, remember a fulcrum point, remember it's like a teeter-totter, okay? You guys know what a teeter-totter is, right? You got this plank of wood on a bar, and if everything is all even at both sides, you know, you can, I guess, have some fun with somebody, you know, going up and down on the teeter-totter with a friend of yours. But if the friend of yours happens to be really, really light, then that friend of yours may get hoisted up into the air and never come back down until you do what? Until you slide closer to the fulcrum point to then even out that weight to allow your light friend at the other side to come on down. Remember that little exercise out there on the playground? Playground physics. Don't you love it? So with this is the same type of thing, is that we look at from a datum point, or this fulcrum in this case, you have something, in this case that weighs 50 pounds, that is 100 inches away from that fulcrum. So with this, is that the first thing that we do is we determine the moment for this particular weight. And this is where I want you to memorize the following equation. And that is weight times arm equals moment. The weight of the object multiplied by the distance of the arm equals your moment, or the effect of that weight at a particular distance. Okay? Weight times arm equals moment. Memorize it, know it, live it, love it, learn it. Okay? Another way to express this equation, also algebraically, would be this. If you took the total moment, I'm going to abbreviate, and you took your total, not tattle, total weight, okay? That would equal your arm or your center of gravity, CG, center of gravity. So simply by re-expressing the formula here, we can also get another useful piece of information to help us here. These are the two things you must memorize. Must memorize. Okay? So, now we'll talk about kind of how all of this stuff kind of comes together. Give me just a second here. Okay. Now, as we look here, we're determining the loaded weight and the CG. So with this, you're going to look at a lot of different ways that you can do this. The biggest thing that I want to impress upon you at this point is this. In order for you to do these calculations, you must resist the temptation to get sloppy. I've seen your handwriting. Lord, okay? You cannot be sloppy in your accounting for your weight and balance calculations. You have to keep everything in order. So, what we're going to do is that we are going to create a way for you to keep your accounting in order. So remember what I said here. Whoops, I don't want that one. That's kind of thick. Let's try this one. Weight times arm equals moment, right? So if we create a table here by which these calculations can occur in some logical fashion, this could help us solve our problems, right? Right. So, we're going to learn how to create a table. Before we do, there's another way to do this. You have a tabular method, which is using a table, and then you have a graphical method, using a graph. Now, I'm going to tell you my bias here. With the tabular method, you're actually working with the numbers themselves. That's what we're working with, just hard data. The graphical method was produced to provide an easier way for pilots to be able to do weight and balance calculations. The problem with the graphical method, in my view, is that not only are you there to try to make basic calculations that your life actually depends on, but you're also being judged by your ability to draw a straight line. There is some cartography or some drafting skills that are required for you to do that. And it kind of depends on how you interpret where the lines intersect is going to help you with your weight and balance calculations for that aircraft. I don't care for the graphical method. I just don't. However, a lot of aircraft manufacturers produce these calculations in graphical form. So we're going to learn how to do it to the best of our ability, but our go-to is going to be the numbers themselves. So you're going to see two different ways to do it: the graphical method and the tabular method. Just know that my bias leans towards the tabular method, where we can actually use the doggone numbers. Okay? Keep that in mind. So when you look at this, if you look down here at like a sample loading problem, you can see that you have these blanks that you fill in. Okay, so here is a column, here is a row. Each row represents a station. Don't know what a station is? Go back to the vocabulary lessons that you had there a couple pages ago and make sure you know what that is. Each one of these refers to a particular station, and at each station there's going to be a weight, and at some point we need to come up with a moment for this weight, because the moment part along with the total weight part is going to tell us where our CG is, and that center of gravity has to be within a prescribed range for that particular aircraft. So we have to know what all that stuff is in order for us to know, is my airplane okay to fly? So that's kind of what we do. But remember, in order to get to the moment, you've got to know what? The arm. So how in the heck do we do that? Well, here we go. In the graphical method, you are asked to take a weight for a particular station to discern the moment. So let's take a look here just real quick. We have the weight over here, we have the moment over here. And what happens here is this. The arm has been taken out of the equation for you. The arm is missing. It is represented by an angular value that the mathematicians and the engineers have put out here on this graph. And by merely putting the weight on a straight line here to intersect with this particular area of this particular station, in this case it's the pilot and front passenger, and then you bring that intersecting line straight down vertically until it hits the moment line to determine what that moment is. Okay? So this is where they get this. They take the arm out of the equation on this stuff. But again, you got to keep your lines straight or you'll never get the correct moment. And that's my problem with these graphs. So we're going to use them, but we're going to figure it out. Then, once we know the total weight over here, the total weight, and we know the total moment here, then we come up here like this, we come over here like this, and we see, does that computation fit within this loading envelope for this aircraft? We have two different categories in this one. We have a normal category and we have a utility category. You can see the utility category is going to be lighter and the normal category is going to be that which is a little bit heavier. So this is how we use this information to see, does everything fit within here? If it doesn't, if that stuff doesn't fit, and let's just say that our final calculation was up here somewhere, would you fly that airplane? The answer there, of course, is no, you wouldn't, because it's the airplane is overweight and it's not within balance, okay? So this is kind of how you use the graphical method, all right? So now, what I want you to do is this. I want you to read the next 5 pages. Remember what your assignment was, add 5 pages to it. Then on Friday, I'm going to show you kind of how it all fits together, okay? So, review this video as you must. Know in here what you've got to know. Remember those bullet points, ding, 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 ding. Remember the formulas, ding, 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 ding. This is going to be part of your note-taking, part of can you keep up with this class? So there you go. Guys, have an awesome day, and I'll see you Friday. Thank you very much.